Solving with imaginary numbers. In this presentation, we're going to talk about how to actually solve using inverse operations, and we're going to be solving quadratics that are going to result in imaginary numbers. So as a review, go ahead and take a few seconds, go ahead and try to solve this warm-up question. If you still need more time, please pause the video presentation at this time, but I'm going to go ahead and proceed. If I were to solve this first warm-up equation, I'm going to go ahead and add 4 to both sides. And that's going to result in x squared equals 4. And then I understand in order to undo squaring a number, I'm going to take the square root of both sides. And that's going to result in x equals plus or minus 2. So one of the key review points is the fact that when we take the square root of an item, we got to make sure we remember plus or minus 2. Because if I substitute a 2 in for x, 2 squared is 4. And if I substitute a negative 2 in for x, negative 2 times negative 2 also gives us 4. So a big kind of hidden fact to remember when we're solving quadratics is that we're going to have plus or minus whenever we take the square root of both sides. Now, that's kind of like a little bit of a review item. But what I want to do at this time is let's take this first equation and let's just change it slightly. And let's actually make it x squared plus 4 equals 0. So again, in the solving process, it's all going to look very similar, but now I'm going to subtract 4 to both sides. And from here, I see to undo the square, I'm going to take the square root of both sides again. But now this is whenever in previous times we'd have said, well, the square root of a negative can't be done per se, so we'd say no real solutions, which is true. However, but now we understand that there is a thing called an imaginary solution. An imaginary solution in this case would mean that that square root of a negative would become an I, and we'd see that this would actually be plus or minus 2i as our solution. So before we used to call this no real solutions, again, that is correct, but now that we understand what imaginary numbers are, we can calculate those imaginary numbers, and we'd have plus or minus 2i. So now we understand that basically our solving process is going to be similar to what we've always done. But now if we have imaginary values involved, we don't put no real solutions. We go ahead and we actually find those imaginary solutions. So again, this is a good time to kind of pause the video presentation and try both of these examples. I'm going to proceed as if you've already had a chance to go ahead and make your predictions yourself. In the first example, we see that pretty basic. I'm going to add 2 to both sides. I'm going to divide by 3. And now I get x squared equals negative 12. So again, I think we can tell that we're going to end up with an imaginary, because I'm going to be taking the square root of a negative. But in this case, instead of the value being a perfect square, I'd have to be able to separate this into negative 4 and 3, which would result in plus or minus 2i square root of 3. So again, we can see that we're going to end up with a plus or minus in our answer. Plus, since we had a negative underneath the square root, that's where the I comes from. Now, something unique in this third example happens right here when we have parentheses. If I have parentheses being squared, I want to envision that just like my x being squared. So I don't want to go ahead and take x minus 3 times x minus 3 and get something big. I just want to focus on isolating this portion of the equation first. So, in order to do so, I'm going to subtract 11 to both sides. I'm going to divide both sides by 2. And now at this step, you can see that again, we have something being squared, so I'm actually going to take the square root of both sides. So on the left, that's going to result in x minus 3. On the right, this would be I square root of 5, but again, don't forget the plus or minus. Now we're not done yet because again, I have the term of negative 3 along with the x. So my final step is going to be to add 3 to both sides, resulting in x equals 3 plus or minus I square root of 5. So a lot of this stems from our ability to solve a linear using inverse operations. But now we're going to be taking square roots in our solving process. And furthermore, if we're taking square roots of negative, that's going to leave us with imaginary values or the variable I.